property, and we're going to be looking at pages 6 through 8 today. And we're also going to look at how can you sketch without a table. So we're going to see if we can draw our parabolas without being given a table. All right, so question number 26 says, what do you need to sketch a parabola? How many points do you need in order to sketch a parabola? 1, 10, 50? Think about this as you answer the questions below. Part A says, can you make a sketch of a parabola if you only know where the Y-intercept is? For example, if the Y-intercept of the parabola is at 0, -15, can you sketch its graph? Why or why not? You're going to say, no, that's not enough information because you don't know whether it opens up or down. You don't know how wide it is. You don't know a lot of pieces of information. Okay? So 1 point is not enough. Part B says, what about 2 X-intercepts of a parabola? If you only know the X-intercepts, can you sketch the parabola? For example, if the X-intercepts are at -3, 0, and 5, 0, can you sketch the parabola? The answer again is no. You still don't know how steep it is. You don't know where the vertex is at. You don't know whether it opens up or down. So just knowing 2 points on the x-axis is not enough. Part C says, can you make a sketch of a parabola with only 2 x-intercepts and the y-intercept? To test this idea, sketch the graph of a parabola that has x-intercepts at -3, 0, and 5, 0, and the y-intercept at 0, -15. Okay? So we're going to do that on this graph over here to the right. We're going to first put a point at -3, 0. So you start at the origin, you count 1, 2, 3 to the left. That puts us at -3. And you don't go any up or down, and you put a point right there. Then we need a point at 5, 0. So again, start at the origin, count 1, 2, 3, 4, 5 to the right. You don't go any up or down because it's 0, and you put a point right there. So we've got a point here, and we also know that there's a y-intercept at 0, -15. So here's 0. We're going to go all the way down to -15 and put a point. Okay? But it's not the vertex. Okay? If that point is not the vertex, we don't know where it's at. We can figure out where the reflection line will be, because if we know these 2 points are on each side of the line of symmetry, we can count towards the middle, go in one, go in another, go in another. That means that our line of reflection is going to be right here through 1, and we know that the vertex should be on it, but we don't know if it's right here or right here. It could be a decimal or a fraction in there. It could be down here. We don't know how wide that parabola is going to be. So we do know where the line of reflection's at, but we don't know where the full vertex is at. It's going to be at 1 something, but we don't know what that something is without the equation or without them telling us. Okay? So for question number 27, it says, in the previous problem, you learned that if you know the intercepts of a parabola, then you can sketch its graph without making a table. But how can you determine the intercepts of a parabola from its equation? Part A says, what is true about the value for all y, for the value of y for all x-intercepts? And what is true about the value of x for all y-intercepts? Here's what's true, is that the y is going to be equal to 0 for all of your x-intercepts, and the x is going to be equal to 0 for all of the y-intercepts. Okay? Kind of backwards of each other. Y is 0 for all of the x-intercepts, and x is 0 for all of the y-intercepts. So when we get to part B, it says, what is the y-intercept of the graph? Y equals 2x squared plus 5x minus 12. Since it wants the y-intercept, we're going to put in a 0 for x. Okay, so wherever we see x in the equation, we're going to put in a 0. So instead of 2x squared, we say 2, 0 squared. Instead of plus 5x, we say plus 5 times 0. And then we're going to simplify. 0 squared is 0, and then anything times 0 is still 0, right? 0 times any number. So 0 times 2 is just 0. 5 times 0 is also 0. Minus 12 is negative 12. That means we're going to have a point at 0, negative 12. For part C, it says, what equation would you need to solve to determine the x-intercepts of the graph of y equals 2x squared plus 5x minus 12? We just want to take the 0, plug it in for y, set that equation equal to 0. So here's what it looks like. It's 0 equals the 2x squared plus 5x minus 12. That's what your equation would look like. Okay. Part D. The solutions to the equation 2x squared plus 5x minus 12 equals 0 are called the zeros of the function. At this point, can you algebraically solve the equation 2x squared plus 5x minus 12 equals 0? Explain why or why not. We say not yet. That means that you will be able to, because there is an x squared term. Okay? So now we're going to get deeper into this thing called the zero product property. The equation you wrote in part C of problem 27 is called a quadratic equation. To solve it, you need to examine what you know about 0. Okay? Study the special properties of 0 below. All right, flip over to the top of page 7. At the top of page 7, it says, Nathan, Nancy, and Gaston are playing a game where Nathan and Nancy each think of a number and then give Gaston a clue about their numbers. Using the clue, Gaston must tell them everything that he knows about their numbers. So for part A, it says Nathan and Nancy's first clue for Gaston is that when you multiply their numbers together, the result is 0. What conclusion can Gaston make? If you multiply two numbers together and 0 is the answer, then at least one of the numbers must be 0, right? Because anytime you multiply by 0, you get 0. Okay? Disappointed that Gaston came close to figuring out their numbers, Nathan and Nancy invite Nadia over to make things harder. Nathan, Nancy, and Nadia all think of secret numbers. This time, Gaston is told that their 3 secret numbers are multiplied together. The answer is 0. What can Gaston conclude this time? Okay, same thing, right? At least one of the 3 numbers must be 0, okay? Because if you multiply times 0, you're still going to get 0. This is called the zero product property. Zero product property. Does it matter how many numbers are multiplied? If the product is 0, what do you know about at least one of the numbers? This is called, again, the zero product times 3 times 0, you get 0. What if you multiply 1,000,000 times 5,000,000 times 80,000,000 times 0? What do you get? 0. You're always going to get 0. Okay? So if the product of 2 or more numbers is 0, then you know that one of the numbers must be 0. Okay? That's going to lead us to question 29. Okay? Question 29 says, now that you will apply the zero product property to solve the quadratic equation, 2x squared plus 5x minus 12 equals 0 from problem 27. Rewrite the equation as a product equal to 0. So we're going to factor whatever it was. It was 2x squared. Let me go back there. Where is it? It was right down here. 2x squared plus 5x minus 12. Okay? That factors to 2x minus 3 times x plus 4, and we set it equal to 0. Now you can write equals 0 on this left side, or you could put equals 0 over here. It doesn't matter which side. Okay? Either this factor is going to be 0, or this factor is going to be equal to 0. One of them is, right? To get 0, one of them has to be 0. Could both of them possibly be 0? Yes. Sure. Okay? We're going to make an example that says either one of them could be 0. Okay? So I'm going to take the easier one first. The x plus 4 is much easier to do, so I do that one first. I set x plus 4 equal to 0. I subtract 4 from both sides, and I get x equals negative 4. Okay? When you get x equals negative 4, that gives you a point. That point is going to be negative 4, comma 0, because we set it equal to 0. Okay? So you're going to go on this graph right here, and you're going to graph a point at negative 4, 0. So you're going to start at the origin. You're going to count 1, 2, 3, 4 to the left. Don't go any up or down, and you're going to put a point right there. Put a point right there. Now I'm going to do the one that's slightly harder. Why? Because it has a coefficient of 2. So we're going to say this factor, 2x minus 3, set it equal to 0. Add 3 to both sides, which leaves me with 2x on the left and 3 on the right. Then I have to divide by 2, and that gives me 3 halves. Okay? Now we're going to graph that as a, well, I changed it to a decimal. I changed it to 1.5. You guys know how to get 1.5 from 3 halves? Okay. So we're going to graph that point as well. We're going to rename that as point 1.5, comma 0. So again, you're going to start at the origin. You're going to go 1 over and then halfway to the 2. Don't go up or down any, and put a point right there. Okay? That's going to give you your other X-intercept. Okay? All right. Part C. Part C says, with one more piece of information, you can sketch the graph of the parabola y equals 2x squared plus 5x minus 12. What is the piece of information that you could use? And you're going to sketch the graph. So the other piece of information you could use is if you use 0 for the x. Okay? So now we're going to plug in 0 for x here. We're going to plug in 0 for x here. And we're going to be multiplying a lot by 0. When you multiply by 0, it's super fast and easy because you always get what? 0. So 0 squared is 0. 2 times 0 is 0.